Okay, everybody, this is Don Wedding calling, and today is, let me think, today is February the, and 2018. We are in Predict 411. This is Sync session number 2, and we're going to be talking about logistic regression and the insurance assignment. So that's today's topic. So Lisa had a question just before I hit the record button. So Lisa, why don't you say your question again?
So my question is for the bingo bonus on the insurance problem when we're trying to predict the target amount. Are we submitting to the Kaggle competition the target amount, or are we submitting the calculation of the premium paid in the second column? I submitted one and I put it under the target amount category, but it was actually the premium that I had calculated.
And by premium, you mean the probability times the damages?
Yes, exactly.
I would, if it were me, if the short answer is really what you want to predict is the premium, because that's what the insurance companies are doing, is they want to know what is the expected risk that you are going to be. Now, you can do that one of two ways. One way you can do it, now going back to homework number 1 where we had that insurance problem, that one I gave you a data set where everybody had crashed their car. So there was 100% damages there, and then, you guys we were already assuming that there was going to be an auto crash. But in this data set, there's a lot of people who don't crash their car. So this is real world stuff. Now, you can approach this one of two ways. One way you could do this is you could just throw all the data in there, the people who didn't crash their car and the people who did crash their car, and just predict the damages, the raw damages. Don't even bring in the probability of a crash. Just say, what's the risk here? Okay? And that's pure premium, exactly what you're saying. And you could do it that way. And that's what you could submit to Kaggle. The other way you can do it is to just filter out the people who did crash their car, predict what the damages are. Then you predict the probability of a crash, and then you multiply those two things together. So you could do it either way, but really what you're going to be predicting here, Lisa, is you're really predicting the premium. That's ultimately what you're trying to predict. So does that answer your question?
I think so.
Okay. So let me do one thing. I'm going to put everybody on hold for 1 second. I forgot to fill my water glass, and I'm already getting thirsty from talking. So can you guys wait 30 seconds? You're supposed to say, yeah, go ahead, Don. I'm hearing nothing. Okay, I'm going to assume it's okay with. Okay, thanks. Okay, guys, I'm back. Okay, so of course now the phones are ringing here. Okay, so hey, who's that? Who's looking at me here? That's Prateem? Okay. Well, guys, I'm ready to get started. So let me share my screen and I'll show you what I've already started. How about that? Okay. And can I get a volunteer? Because when I start showing my screen, I can't see the chat window. So can I get somebody to volunteer to keep an eye on the chat window for me? Anybody? Lisa, you sound like a person who's going to watch that chat window for me. Can you do that for me? I'll do it. Well, that means you got to take yourself off of mute when something happens and you get a chat. Then you throw yourself off of mute and then interrupt me. How about that?
Fine.
Anybody? Okay, great. I need that human interaction here before I can move along. So let me share my screen, and I'll show you what I've done so far. Okay, so this is something I just cranked up as about an hour before the class started. And don't worry, everybody. I'm going to post this code so you're not going to be stuck, okay? So you don't have to like feverishly take notes. Okay, so here's what I did, and I'll start over from scratch, and then I'll just move this other code in here. So this is the data set that we're working with right now. So sorry. And by now, you guys should be old hats at this, where this is, no big deal at all. All I'm doing is I always take my data set and I copy it into something new. And the reason why I do that is because you just learn that in the real world is you always make copies of your data because you'd never want to overwrite it. It's a nightmare. So let's just do that real fast, and then we're going to do a proc means data equals temp file nmiss mean, and then we're going to do var numeric run, and then we're going to do proc frequency data equals temp file n table character missing run. Okay, so what this is going to do is I'm just loading in all my libraries. I make a copy of my data set. And the first thing I always do is I explore the data. You can do this with proc univariate. You can do it with proc means. I use proc means. That's what I was taught. But it's not better than univariate. It's just different. This is where I grew up using means, and that's why I always default to that. So if I go over here and I hit proc means, what I always do, and this tells me I've got some missing values that I'm going to have to fix. Okay? So I've got these missing values that I'm going to have to fix. And then the second thing that I'm going to do is I come over here and I run a proc frequency on the character variables. Now, when I do numeric, this is going to give me all of the numbers. So I don't have to, otherwise I would have to go over here and type in, kids drive, age, home, years on job. I would have to type all of these guys in, and I could do that just as easily, but this is the shortcut is just to do numeric. The second thing I could do is, again, this is a shortcut, is character. This is going to give me all of my character variables, and I'm going to get a frequency of all of those. So if I do this, you're going to see that we have here single parents, married versus not married, male versus female, education, your job, car use, commercial versus private, and then the car type. So here's the first thing I did. Now, this is what I want to try. First of all, let's predict whether or not the guy, let's assume the guy's going to crash the car, okay? And I'll show you what I wanted to try. And I do not even know if this is going to work, okay? I was just thinking about it. It was mulling and creeping and crawling around in my head as I was driving, and I said, I wonder if this is going to work. So, you know what? It makes sense, and what I always say is, if it makes sense and it gives you a good answer, it's right. Well, what I want to try is going to make sense. Now, the thing is, I want to try to see if it makes sense, and we'll decide as a team here if this was right. Okay, what we did in the past was this. At this point, here's what we did. proc reg data equals and what's our target amount? Okay. So what we did in the past was we did a regression on everybody. Okay. So so basically you see here that we have a minivan and a panel truck and a pickup truck and a sports car and a van and a SUV. So in fact, let's just go back to the previous assignment. Okay. So let's go over here, linear regression, insurance. This is what we did in the last sync session. Go back up here. I'm sorry, folks. Let's try this one more time. So let's go back. For the students who were there at the last sync session, the students asked me to try to solve the insurance bingo bonus problem. So let me just run this guy down. And what we did was we solved it right here. And we put in all of these variables like the income and the blue book and the car age and all that fun stuff. And we put it all in here. And we ended up with an R squared, an adjusted R squared of 1%. Okay. And then if you look over here, the car age, the model that came out was nothing more than the blue book value of the car times, so our car, when we try to predict damages, was $4,000 plus 13% of the blue book minus $62 for every year old the car was. So that's what we did. And it was a real simple model. So here's what I was thinking about today is I thought, well, that's kind of crazy because in a way, we have a lot of different cars here. So let me delete this here. And you'll notice that, let's go back over to today's sync session. We've got a lot of different kind of cars. And we're right now building our damage model, assuming that every car is the same. So in other words, if I'm predicting the damages of a sports car and a panel truck, like a moving van, I can't believe that the damage model for both of those guys is going to be the same. So I was thinking, I wonder if we make a separate model for each one of these guys and see if we can get a better answer. So does everybody sort of see what I'm thinking about, and what's everybody's thoughts on that? You can type it into the chat window if you think that's crazy. Lisa, you get to read it, and if you think it's crazy, then let me know, but I just thought maybe we'd try to build one or two models for each of these separately and see if we get a better answer. So what are people typing in there, Lisa? Nothing?
Nobody's saying anything.
Uh-oh. Have I lost everybody? Does everybody understand what I'm proposing?
I like the idea of it personally.
Well, that's that's high praise because I don't think anybody else is listening. Thanks for. So I got Lisa on my side. Thank you, Lisa. But nobody else is saying anything. Come on, people, help me out.
We have a yes, let's go ahead with this approach from Panesh.
Okay, well, so I've got Panesh on my side. So I've got Panesh and Lisa, but nobody else, huh? Okay.
Raphael, wow.
Okay, we got everybody. We've got a quorum at this point. Okay, so let's do that. And before I do that, I want to make sure I've got all my missing values fixed before we continue. Let's see here. I just want to see if I got all of my missing values fixed. Is there anybody else with any missing values? Looks to me like we've got all of our missing values. They're all fixed. Everything looks good. No missing values. So I think we're looking pretty good here. So what did I do in the meantime? So this is, I'm sorry, this is, go back. Okay. So what I'd like to do now is, let me look one last time just to make sure that there's no missing values. I've got so many files open. If we have any missing values, I've fixed them already. Okay, I just don't want there to be any missing values. Nope, no missing values. Great. Okay, so here's what I did. We're going to use Proc Regression to figure out the missing value, or to figure out the damages model. Now, the problem with Proc Regression is it doesn't take categorical values. So in other words, unlike logistic regression, which is just fine with that, I can't do that with Proc Regression. So in that case, I have to convert them into flags. So for example, if you are a doctor, I created a flag, okay? And the flag is going to be 1 or 0. So those are numbers. And so what I'm saying is we have here a job. So if your job is a doctor, now I could do something like this and put doctor, comma, lawyer, and then maybe make this white collar if I wanted to, like a white collar job. I could do something like that. So if you want to, you don't have to make each one separate. You can merge them together. Just put doctor, comma, lawyer, comma, whatever. And so if the job is a doctor or a lawyer, this will be a 1. Otherwise, it's a 0. So that's kind of how this is going to work. And I've done that for every single one of the variables in this data set. So what I did was I said, okay, if you're a single parent, if that value is in yes, then I'm going to get that, it's going to be a 1. Otherwise, it's a 0. The marital status has a yes or a no. So I'm saying if your marital status is yes, then this guy is married. If you're male, then the flag for male is set to 1 or a 0. So that's what I did. And then I throw them away. So I don't want it, once I've got this guy converted over into a flag, I get rid of it. I don't want it floating around here. I just want to keep just numbers. The other thing I did was I have these variables for your education. So you could be a high school student, a bachelor's, a master's, or a PhD. So I thought I would convert those over and say, okay, let's assume high schools are 1, bachelor is 2, master's degree is 3, and a PhD is 4. We could do this. You could convert it into other ways too. You could say that high school, let's assume that if you've got no education, but if you graduate from high school, that's 4 years of schooling. And if you got a bachelor's degree, that's 8 years of schooling. And a master's degree would be another 2 years on top of that, so that's 10. And then a PhD, maybe another 4 years on top of that. So 14 years of school. We could do something like this if you want. And again, that would make sense. So if you want to, does anybody have a preference as to how we code up the education level? Do you like this, or do you want to just use 1, 2, 3, 4? So Lisa, take a quick vote on that for me.
Yeah, this would be something new. Yeah.
You want to do it like this instead?
Yeah, go ahead.
Okay. Let's do it this way. Okay. So, and we'll put a little note here for future generations. Converting numeric so that it is equal to the number of years of. Somebody keep yourself on mute if you're not talking, because I'm hearing something in the background there. Okay, so anyways, I've converted these guys all into numeric, and then I went down here, and if I had some missing values, like age, I said, okay, if the age is equal to missing, I just imputed it to the average, 43. And if years on job was missing, I imputed that to 10 years because that's the average. So I imputed all these guys into the average. I didn't do anything sophisticated. I just wanted to keep it pretty simple. Okay, so what I want to do right off the bat is, let's do this. Whoops. Okay, so what we're going to do is we're going to start off by, we'll build a real quick and dirty model to predict what it's going to cost us if we have a sports car that crashes, okay? So let's take this guy here, and this is our completely ready data set right there. And we'll hit run. Okay. Now, how many sports cars do we have? We got 907 sports cars. Okay. So the first thing we're going to do is we're going to build a model for sports cars. Okay. So what we'll do is we need a data set for sports cars. So let's say let data set sports car equals CS. There we go. Okay, so here's what we're going to do. Let's go over here and let's say data ampersand. What's our name of our data set? This guy right here. Did we run this? Let's make sure we ran it. Set temp file, run. So this is going to copy all of our data from the temp file and dump them into the sports car. However, we don't want that. We only want to use some of it. What do we want to use? Well, the first thing we want to use is we want to use the data where it's a sports car. So we're going to say if the car type is going to be a sports car, if car type in sports car, let's do him. So if you're going to be a sports car, then we're going to let you go through. Otherwise, forget it, okay? And then we're going to say that we only, because we're predicting a damage model, we only want to keep the people who crashed their car. So we're going to say if target amount is greater than 0. So this is the people who did crash their car. And let's just see what's left when we're done. Proc means data equals this guy And let's see how many are there and what's the average damage. And let's drop the flag. We don't need that. So drop the target flag. Okay, and let's run this guy. See what we get. Hopefully we've got some data left after this is over. Okay, so we've got 304 of these guys, and this is all of the variables we have. So let's collect this. Copy. Paste. And what we need to do is indent them a little bit, otherwise it will drive me nuts. And selection equals stepwise. Run. There we go. So let's see if we get a different model than before. Remember, before it was like 4,000. I think that when we used all of the data, I think it came to something like $4,000 plus 13% of the blue book minus $65 for every year old the car is. So let's see what this gives us. This gave us what? Wow. Gave us a lot of variables. And what's the R squared of this guy? Our adjusted R squared has jumped to, what is that? This is our R squared. Oh, I think we can't put all of the jobs in there. I think that it's perfectly separable. Let's leave one of them out. Let's leave out let's leave out the clerical person. Okay. Quit. Okay, let's see what we get. Okay, did we get any errors? ODS graphics, more than 5,000 points have been, I didn't say to print anything. Okay, and what do we get for an R squared here? I can't find the adjusted R squared on this guy. Does anybody see it? Well, it doesn't matter too much because what we're looking at here is there's a lot, the model is a lot more different than it was before. So, in other words, married people have less damage, doctors have less damage. If your license was revoked, you had more damage. If you're in an urban area, you had more damage. So a lot of this stuff seems to make sense. So there you go. Here is our model. And it seems to be a little bit more accurate. The R squared value, I'll tell you what, let's not do a stepwise selection. Let's just, because maybe this stepwise selection thing is what's throwing it off a little bit. Because I want to see what the adjusted R squared is. Yeah, there we go. So we have an adjusted R squared of 6%. Now remember, before we had an adjusted R squared of only like 1%. So if we, maybe a model using only the sports car here gives us, a more accurate model here. So, am I losing everybody? I'm hearing total silence. Do you guys understand what I'm doing? Do you agree with what I'm doing? What's going on here?
Yeah, I understand.
Okay,
Yeah,
great.
if here you have used a lot of other flags, which you didn't use before. So
Yeah, but I
this
have
model
used.
is
Yeah, you're right that I didn't use these flags before, but I have used them in the past in other classes, and they've never been significant. It only seems that now that I'm pulling out the sports car specifically, it seems to be working. So, I might do something with this where, I might,
so. Go ahead and add another, just not just the sports car. Add another the type of car and see are we getting anywhere close? That
okay,
might tell us the story.
okay. Well, I'll tell you what. Let's do. Let's take this part out and put it in for all the cars. Okay. So if we put just all the cars in, nope, we've got an adjusted R squared of 6%. So,
Right.
there you go. That's
Yeah.
interesting. Maybe it's this flag here that's not. Maybe it's maybe we didn't use these flags in the past.
Yeah.
So there
Dalton,
you
you
go.
also have another question.
Okay, go ahead.
Andrew wants to know, why did you use temp file data set and not DS sports car?
Oh, yeah. That was a test, Andrew. Let's try it now. Yeah, that'll do it. Let's find out now. Yeah, temp file had a lot of stuff in there, like up to and including it had stuff like those flag variables. In other words, it was the people who didn't crash their car were in that data set also. And if you didn't crash your car, there was a lot of zeros in there. Okay. Now we're getting somewhere. Okay, look, 1%. That's not good. That's more like it. Okay, that was the answer I was expecting. Selection equals, let's put this back. Okay, 1.83. Now let's do it with just the red guy, the red sports cars. The sports cars. Let's see if this works. Okay, look at that, 5%. So when we do just the red sports cars, it seems that it's $4,000 plus 13% of the book, the blue book, minus the car age. But if you're a professional and you crash your car and you have a sports car, it costs more. I don't know why, but that could be something right there. So maybe if you're a doctor and you have a sports car, your car is probably a Corvette versus versus a Camaro or something like that. So okay, let's go with this. So let's do our score code, and we'll call it damages. That okay, so our score code is going to look like this. The predicted damages is going to be 0. Okay. What you always have to do is we're going to put in our everything we did to prepare our data gets put in there. Okay. And now we're going to say if the car type is equal to a sports car, then do end. Okay, and we're going to say that the predicted damages will equal $4,500 times Blue Book times this times, if you're a professional person, in other words, a doctor or an engineer or whatever, and then every time your car gets older,
One more question. Sorry, this is Andrew again. Why aren't you using test file for this? Why are you using in file?
well, because now we're scoring it, okay? This is going to be what we're going to do is this is now the logic to score new data, okay? Temp file, we've already taken and tested. We've already adjusted.
Test file, not temp file, test file.
We're gonna put test file in there. Well, we may as well do it now. How about that?
I just want to make sure I'm understanding which data set we're running against.
No, eventually we're going to have to do it to the test file. You're right. We may as well do it now. Andrew, you're keeping me on my toes tonight. Test file. How about that?
I feel better. Thank you.
Okay, I'm glad you're keeping me honest. Okay. So how about this? Let's do another one for a different kind of car. Or do you want to do a couple of different cars? Like, okay, so we have a model for the sports car. Let's do something else. Let's do I don't know, what other kind of cars did we have? I forget. We'll just do two. We'll just do this. We'll do how about trucks? Panel truck, pickup truck, and minivan. How about that? You guys okay with that?
Sure.
Okay, great. Trucks. Okay, we'll come down here and
Hey Don, this is Preetham here. I have a question.
okay, go ahead.
Uh, so that the sample file that we have, the one that we are creating the model against, does it make sense to split that file into like 70-30 and then create the model with 70% of the data and then validate it against the 30%? Is that a good idea, or should we validate against the test data itself?
Well, you can't validate against the test data because you don't know the answers. Only I know those answers. The short answer is, should you? Yes. Are we? No, we're not, because two reasons. One is I don't have time right now to do it. And the second reason is that we don't have a lot of data to play with here. The less data I have, the more likely I am to not use a holdout sample. So I don't want you to think that this is great technique. You should have a holdout sample. That would be a good idea. We're kind of driving our car without the safety belts on. Not necessarily. It's not going to be fatal, but idealistically we should. So let's see what we got now. Now we have an R squared for the trucks of 3%. Again, that's still better than what we did see. So now what we see here, we've got the blue book value. So we have the blue book value, MVR points, flag for the parent. Okay, I'm not crazy about this negative sign there, but let's go with it. Then we would do and we should probably do something else right here. Well, we'll do that later. I'll show you what I'm going to do in a minute. So this one's going to be that the P damages will equal that times and then we'll do one for the rest of them. Oh. At the very end, I'm going to do this. If P damage is less than 0, then actually let's say $100. I'm going to say that everybody should have at least $100 worth of damages if they crash their car. So we're going to do that. And P damages equals 100. So already I'm going to calculate the P damages for sports cars, trucks, and then we're going to do everybody else. How about that? So who's everybody else? Everybody else is going to be what? What's our last cars? Minivans, trucks, pickups, vans, and SUVs. Okay, those will be the last guys we do. We got 12 minutes. I think we can do it. What do you guys think? Run them. Am I losing people, or this is a strangely silent group of students tonight, and I'm getting worried that I'm wasting your time and that you're not following along.
No. We are watching the
Okay.
way you are doing it.
Okay. I don't even know if this is going to work when we're done, guys. But here we go. So we got the vans, we've got the cars, blah, blah, blah. Let's try this again. But now let's do it with vans. Okay, and this is about 1.2%. So this one didn't seem to do all that well, but let's see what we got. So if you're male, you're going to cost us more money. Your education, the more you're educated, the more money it's going to cost, and managers seem to cost less. Don't know why. But this one doesn't make all that much sense, so who knows? But I would probably, in the real world, do a little bit more investigation here. But let's just go with this. Then do and I don't even know if this is going to work. Let's find out. Okay, there you go, guys. So proc damages are okay. Let's see if that works. Uh-oh. Procedure mean not found. How about proc means? There we go. Minimum is 2,500. Maximum is 11,000. Mean is that. Seem reasonable. Let's see if I make sure we don't have anybody missing. Always make sure that you don't have anybody missing. Nope, nobody's missing. So, okay, so now we've got this guy right here. Just for fun, let's quickly do a proc logistic. Temp file. Let's not use it. Let's just go really, we're just going to take these guys as is. Nothing fancy. Model equals our model target flag equals this guy. Run. Okay, let's do this really fast. Okay, so here's our final model here for the our probability of crashing your car. So this is the model that says we're going to crash our car or not. So, and let's see. I don't know what the area under the rock curve is. Oh, I look for the concordant percent is, the C statistic is 79. So our area under the rock curve is 79%. Let's just do this model really fast. Okay. So right now we have the damages right there. Let's do the probability that you're going to crash. Okay. So I don't know. I think we have to put reference equals 1 on here. What does anybody know the syntax off the top of their head? Like, give me a second. I want to make sure that we do this because I want to make sure I don't do this inadvertently the wrong way. Wrong one. Ah. Give me 1 second. I think we're running out of time. We got 4 minutes, but I bet I can do it. This is the syntax I wanted right here. So this is going to make sure that this is going to make certain that Proc Logistics is going to give me the probability that people crash their car as opposed to not crashing their car. Both are equally correct, but we just want to make sure that we're calculating the right thing. Okay. So here you go, guys.
So 0 means probability of crashing the car, and
yes,
1 means.
Yeah, the 0 means that you don't crash your car. So if you say reference is equal to 0, that means that he's going to give you in reference to not crashing your car. So what's the probability beyond crashing your car?
Okay.
If that makes sense. That's what that means.
Okay.
Now, I'm not doing any exploration of this model at all, okay? I should be, but I'm not. I mean, I should be examining these coefficients and all sorts of, there's what they call good technique, and I'm not doing any of it. So, as they say, don't try this at home, kids, but these negatives are killing me. I don't even think I have to put the parentheses, but I've got issues. That's what I do with the little extra money that I earned from teaching at Northwestern. I use this money for therapy. So I've got a lot of problems. Not the least of which is everything has to line up. Because if it doesn't line up, it drives me nuts.
No, sometimes that's a good habit, though.
Well, at least you're enabling me. You're making me feel good about my issues. So this is who's that again talking?
Pinesh.
Pinesh, you're going to get some bingo bonus points for making me feel good about myself. I'm just kidding. Again, you know, if you use this as sort of a cookie cutter prototype, that's fine. But be careful. You don't want to just take this blindly because, quite frankly, there's probably a bunch of errors in here, and some of these models may not make sense. You gotta do your homework on these things and really make sure that everything is reasonable. Okay, so here's what we're going to do. Is I got this probability here, and what is this? When you do a proc logistic, what does it give you? Anybody remember? It gives you the log odds.
Right.
So we got to convert this guy to odds.
Right. So you're saying we have to go through three steps to finally get the probability?
That's right. So the first thing I usually do is I try to say that if you know, P crash is less than negative 99, then P crash equals minus 99. This is because I'm about to do an exponential, and I just want to make sure that, you know, the math is still correct. However, the computer may start choking on the numbers if they get too large. So beyond a certain point, it's going to be 0 or it's going to be 100%. So I'm just going to say that at 99%, and then we're going to say P crash is equal to the exponent of P crash. And then we have to turn this to probability, which is the probability is equal to that divided by 1 plus that. And so that's the probability that he's going to crash his car. And so the actual premium or the damages, you know, let's just make sure that everything is right. Well, this guy should definitely, let's make sure if, I want to make sure that there's nothing wrong with this number. Okay, crash, nobody's missing. The minimum is 0. The maximum is not a very big number, is it? In fact, it's the same number, isn't it?
Same number, yeah.
That's interesting. Let's try one more time, guys. I probably made a mistake somewhere in here, but well, clearly I did, but let's find out. My crashes are all missing. That's not good. Look at that. This is why you check your answers, guys. Oldest claim. Anybody see where I got the error in here somewhere? Anybody?
Is it the bracket?
What does he say? What are you saying?
Is it the bracket on the flag single parent? It's missing the
flag single parent. Is there a bracket there?
Should it be compared to the other ones below? Oh no, they are negatives. I'm sorry.
Yeah. Well, here's how we're going to do it. Watch this. Oh, well, let's do plus 0. Okay, let's get rid of half of them. Somebody's giving us trouble. Who is it? Well, they seem to. Well, P crash. Wait a minute. P crash is working now, right? Okay, we're getting close.
By the way, on the side note, how do you comment out a group of lines?
Oh, you hit Control and you hit the /.
Oh, okay.
Oh,
Good to
and
know.
then to comment them out, you hit Control//. And we've got the 498 students. Give me a few minutes here. We're just finishing up, folks. I hope you're not hating us here. Okay, number missing. So now we found that we got some missing ones in here. So something's wrong. It's one of these guys. Professional. How about that? There you go. Lisa, this was your fault. Do you know why it was your fault, Lisa? Because otherwise it would have been my fault, and we know that's not the case.
It's usually my fault, so I'll take it.
There you go. See, this will work now, guys. Watch this. Okay, we're almost done. We're almost done. Almost done. This is why you check your answers, people. Minimum is 5. Maximum is 94%. There. This is as easy as falling in love. Now we're going to have a variable. We're going to call it Kaggle. And this is what we're going to submit to Kaggle. And it's going to be the probability that you crash times the damages. There you go. And then what we would do is you would print out proc print data equals damage, and you would do var index Kaggle. Or I'm not sure, Kaggle, it's got a different name that you got to submit to Kaggle, but you guys get the gist, right? Does everybody see what I did just now?
Yeah.
I'm only hearing one yeah. I want to hear a chorus of yes from all of you.
Yes.
Andrew, what about you? Help me out.
I'm still with you.
Okay, great. That's what I want to hear. Perfect. So you guys, there we have it. I don't even know. This could be the best model ever submitted, or it could be horrible. I might submit these numbers later on tonight to see how they did. I'll post this code later on for you guys, okay?
Thank you.
Okay. So here we go. Sharing. And for my 411 or 498 students, my 411 students, you guys are free to drop off, but I would recommend sitting in on this real fast because it could be a lot of fun to watch. These guys are going to do their show and tell on various techniques that they're using for 498. Let's see. Why? Okay.
Are you going to stop recording this section?
Yes, I am right